You've been using the wrong AI for coding. Pause. I spent 30 days running the same 5 real-world coding tasks through both Claude and GPT-4, and the results shocked me. Not because one was better overall, but because each one failed in a completely different way. And if you're picking your AI tool based on vibes or YouTube hype, you're leaving serious productivity on the table. Pause. Stick with me, because by the end of this video, you'll know exactly which tool to reach for and when, and you'll never waste an hour debugging AI-generated garbage again. Section Problem. Here's what most developers get wrong. They treat Claude and GPT-4 like they're basically the same thing, just two different chat boxes that spit out code. Pick the one with the nicer interface, right? Wrong. Emphasis, dead wrong. These two models have fundamentally different failure modes, and that distinction matters more than any benchmark number you've seen on Twitter. I see this all the time in developer communities. Someone posts, "I asked GPT-4 to build me a REST API and it gave me garbage." Someone else says, "Claude is too slow and verbose," and both camps are missing the point entirely. Pause. They're not testing the same things. They're not stress testing edge cases. They're giving the AI easy wins and then acting confused when it falls apart on anything real. So I decided to actually do this properly. 5 real tasks. The kind of tasks that show up in actual production work, not write me a function to sort a list. We're talking multi-file refactoring, debugging race conditions, writing tests for legacy code, parsing ambiguous requirements, and building a feature from a vague product brief. Let me walk you through every single one. Section Solution Emphasis. Task 1. Multi-file refactoring across a 2,000-line codebase. I gave both models a messy, real codebase, a Python backend I'd actually worked on with inconsistent naming, mixed patterns, and a few architectural mistakes baked in. The task: refactor it to follow clean architecture principles without breaking functionality. GPT-4 dove straight in. It produced code fast, looked great on first glance. Pause. But here's the problem. It made up 2 function names that didn't exist in the codebase. Confidently, no hesitation. If I'd just copy-pasted that output, I would have spent an hour hunting a bug that wasn't a bug. It was a hallucination. This is GPT-4's core failure mode on complex tasks. Speed over accuracy. It optimizes for the appearance of correctness. Claude? It asked me 3 clarifying questions before generating a single line of code. At first, I was annoyed. Then I realized 2 of those questions were things I hadn't thought through. The refactor it produced was slower to arrive, but it was actually deployable. Pause. Round 1 goes to Claude. Emphasis. Task 2. Debugging a race condition in an async JavaScript function. Race conditions are notoriously tricky. The bug only appeared under load. Classic async timing issue. I pasted the code with a description of the symptoms and asked both models to find and fix the bug. This time, GPT-4 actually performed well. It identified the issue within seconds, correctly spotted the missing await keyword causing the race, and explained why it happened in plain English. Clean, accurate, fast. Pause. Claude also found the bug, but spent 200 words explaining the theoretical background of async execution before getting to the fix. If you're a junior dev, that's gold. If you're a senior engineer on a deadline, it's noise. Pause. Round 2 is a draw. It depends entirely on who's watching the screen. Emphasis Task 3. Writing unit tests for 10-year-old legacy code. This is where things got genuinely interesting. Legacy code is the bane of every developer's existence. No documentation, surprising side effects, global state everywhere. I gave both models a 300-line legacy PHP module and asked for a comprehensive test suite. GPT-4 wrote tests that looked perfect, structured, readable, proper assertions. Pause. The problem? It tested the code as if it were well written. It didn't account for the weird global state mutation happening on line 47. It didn't flag the implicit dependency on a database connection that would make 6 of its tests fail in CI. It wrote tests for the code it wished existed, not the code that actually existed. Claude explicitly called out 4 potential gotchas before writing a single test. It wrote the tests around the actual behavior, including the ugly parts, and added comments explaining which tests would need mocking. Pause. In real production use, Claude's output saved me probably 2 hours of test debugging. Emphasis. Round 3 goes to Claude, and it's not even close. Emphasis. Task 4. Parsing ambiguous requirements into a technical spec. This one surprised me the most. I gave both models a paragraph of genuinely vague product requirements, the kind a non-technical PM writes at 11 p.m. before a sprint. Users should be able to manage their preferences easily across devices. That's it. Turn that into a technical spec. GPT-4 produced a beautiful, detailed technical spec. Sync architecture, API endpoints, conflict resolution strategy. Impressive. Pause. But it made 8 assumptions without labeling them as assumptions. It presented speculation as fact. That's dangerous. That's the kind of output that gets approved in a sprint planning meeting and then blows up in week 3 when the PM says, "That's not what I meant." Claude produced a spec that was maybe 20% shorter, but it explicitly flagged every assumption with a bracketed note. Assumption, confirm with product. It gave 3 different interpretations of the core requirement and asked which direction to pursue. Pause. For solo projects, GPT-4's speed is fine. For team environments where misalignment costs money, Claude is the right call. Round 4 to Claude. Emphasis. Task 5. Building a feature from scratch using a vague brief. Final task. I gave both models this prompt. Add a dark mode toggle to a React app. Make it feel premium. No component library specified, no state management preference. Just make it feel premium. GPT-4 built something functional in one shot. Clean toggle, CSS variables, persisted to local storage. Honestly solid. Pause. Claude built the same feature, but it also added a system preference detection hook, a smooth transition animation, and left inline comments explaining every design decision so I could customize it. It was 40 lines longer, but it was the difference between a feature and a polished feature. Pause. Round 5 is subjective, but if premium was the brief, Claude delivered premium. Section, proof. So here's the final scorecard and the honest truth about what I learned. Emphasis. Claude won 3 out of 5 tasks outright. GPT-4 won the speed round and tied on debugging, but raw wins don't tell the full story. The pattern I kept seeing. GPT-4 is optimized for impressive first impressions. It produces output fast, it looks polished, and it's right maybe 80% of the time. Pause. The problem is that in software, 80% right is often 100% broken. That 20% failure rate, especially when it's confident hallucinations or hidden assumptions, is exactly what causes 4-hour debugging sessions. Claude is optimized for accuracy over speed. It asks more questions. It flags uncertainty. It produces output that's longer and sometimes slower to arrive. But in a production context, that behavior saves time overall. I ran a rough time audit across all 5 tasks. Total time to working, deployable output, including my debugging time for errors the AI introduced. Pause. GPT-4 total, 4 hours 20 minutes. Claude total, 3 hours 5 minutes. That's 75 minutes saved per 5 complex tasks, just by picking the right tool. If you're coding 4 hours a day with AI assistance, that compounds fast. And here's the thing nobody talks about. The failure modes predict the use case. Use GPT-4 when you need a fast prototype, a quick code explanation, or a debugging assist on a well-defined bug. Use Claude when correctness matters, when requirements are fuzzy, when you're working in a team, or when you're touching legacy code you can't afford to misunderstand. Section CTA. So there it is. 5 real tasks, 1 clear pattern, and a framework you can actually use tomorrow. Pause. The developers who are winning right now aren't loyal to one AI. They're fluent in both. They know the failure modes before they hit them. If this breakdown was useful, subscribe. Because next week, I'm going deep on something that almost nobody is testing yet. Emphasis. What happens when you give AI agents access to your actual code base and let them run autonomously? The results are equal parts impressive and terrifying, and I have the receipts. Pause. You don't want to miss that one.